This skull was created by the artist Damien Hirst. It is decorated with 221 grams of diamonds worth £15 million. Diamonds are a form of carbon, but the same mass of normal black powdered carbon is worth about £1. Simple molecular covalent substances include gases such as hydrogen, methane, oxygen and carbon dioxide, and liquids such as water. These substances have low melting points and boiling points because there are only weak forces between the neighbouring molecules. An electronic current is a flow of charged particles. The atoms in a simple molecular covalent molecule have not lost or gained any electrons, so there are no charged particles that can move around. These substances are poor conductors of electricity. Some covalent compounds form giant molecular covalent substances. These consist of billions of atoms all joined together by covalent bonds. Most giant molecular substances have high melting and boiling points. This is because all the atoms are joined together by strong covalent bonds, and a lot of heat energy is needed to break these bonds. Sand is made of silicon and oxygen atoms joined together in a giant molecular structure. Sand grains are very hard. Carbon can form two different types of giant molecular structure: diamond, which is very hard, and graphite, which is very soft. Diamond and graphite have very different properties because of the different ways in which the carbon atoms are arranged. Both have very high melting and boiling points because of the strong covalent bonds between the carbon atoms. There are also differences in the properties. Diamond is very hard because all the atoms are joined with strong covalent bonds. Diamonds are used to make cutting tools. Diamond does not conduct electricity because there are no free electrons or charged particles to move around. Graphite easily rubs away in layers because although the covalent bonds within the layers are very strong, there are only weak forces between the layers themselves. It is soft enough to be used as a lubricant. Graphite conducts electricity because there is one electron from each carbon atom that can move along the layers. This means that graphite can be used to make electrodes.